So here's a problem that's given. It tells you there's 3 different resistors and that they're in series. And then it tells us it's hooked up to a 12-volt battery. It asks us to solve for total potential difference, total current, and then the potential difference and current for each resistor. So step 1 is to get your circuit drawn. So 3 resistors in series being where there's only one pathway for the electricity to flow. I typically start drawing circuits from the battery. All right, and you can draw the resistors any way you want, but I typically, when there's 3, draw one on each side and one on the back. I come around and go, and I'm going to finish off the battery. All right, once you have the general circuit drawn, I'm going to label the battery. It tells us there's 12 volts. The first resistor, we have 4 ohms. Second, 6 ohms. Third is 8 ohms. All right, so at this point, our series circuit has been drawn. From there, we can start to solve. First thing, it says, okay, well, what is the total potential difference? Well, our total is going to be what's coming from the battery. That's given. Easy peasy, 12 volts. Done with total potential difference. All right, so next is total current. Well, total current, we need to consider Ohm's law, okay? So we're given total potential difference. We're asked to find total current. Well, if you look at our equation, we need the total resistance in order to solve for total current. So using Ohm's law, we're going to first solve for total resistance, which is also called equivalent resistance. And let's go ahead and make note that this is equivalent resistance in series. All right, well, if you go to your formula sheet, equivalent resistance in series, you simply add them up. All right. And so here we get a total of 18 ohms. All right, so once you have total potential difference and equivalent resistance, you can use Ohm's law to solve for total current. Okay, so total current is going to equal the total potential difference divided by the equivalent resistance. From here, it's just plugging in what's already written above. Going to the calculator, and we see there's total current is 0.67, and the unit for current is amps. Now, also, at this point, go back and look at your formula sheet for under series. What you should notice is that the current in a series circuit, it stays the same throughout. So the total current also tells us the current across each resistor. So now we have total potential difference solved, we solved for total current, and we've solved for current over each resistor. So what does that leave? Well, now we need the potential difference in each resistor. So in other words, V1, V2, and V3 is what needs to be solved for. Okay, so go back to Ohm's law. We see potential difference is current times resistance, and it's going to be specific to each resistor. Oh, this is 3. All right, we know that the current is the same, so we can go ahead and plug that in for each. And then multiply by each resistance. So resistor 1 was 4, resistor 2 was 6, and resistor 3 was 8. Go to your calculator, plug in. Okay, we see 2.68. Unit for potential difference is volts. 0.02 volts. Last one should come out to 5.36, final unit volts. And if you go back to your formula sheet, what you're going to see is that the total voltage should equal the sum of the potential difference across the circuit. So that's the way you can go back and check yourself.